residential area will soon take shape on this empty space. Before construction begins, however, we are required by law to first look for traces of the past. Any digging in the soil could destroy these traces, because the past is not just behind us, but also below us. One of the most extensive mechanical drilling investigations in the Netherlands is being carried out in Almere-Oosterwal, an area of 200 hectares. Not just the scope, but also the innovative way of doing research has made this project unique. A team of scientists made up of different disciplines is analyzing soil samples from the site to determine traces of plants and animals, the precise composition of the soil, and the exact date of the landscape. In so doing, the scientists are unraveling the history of our distant ancestors and making the invisible past visible again. Thousands of drilling points are systematically plotted using GPS.
En feitelijk wat we doen is dat we, voordat we het veld ingaan, maken we al een plan van waar we de boringen willen zetten. En aan de hand van speciale computerprogramma's kunnen we die boorpunten op een kaart zetten.
And this is the first step in reconstructing the past landscape. The GPS shows that we are now almost 4.5 meters below sea level. Water has always influenced the landscape. If the seawater or the water in the rivers rises, the groundwater level rises and trees and plants can grow. Peat is formed when the rising water drowns the land. A clay soil is left behind when the sea or river water recedes. The top layer of clay here in the polder belongs to the old seabed of the Zuiderzee. We drill into the ground up to a maximum of 12 meters deep with an aqualock machine. The different colors that we can see in the drill core alternate between grey for clay and brown for peat. This tells us that this area had periods when it was underwater and then became swampy or dry. When we look at the drill core, we can see that the landscape has gone through many changes, from prehistory up to the present day. Each core is very carefully analyzed, and the data turned into graphs so that the soil type and depth can be clearly determined. All these cores together help us to understand the ancient landscape. This is very important. It's only when you know what the landscape used to look like that you can determine where people lived. To find out more about the landscape, various scientists are investigating the soil samples.
Dit is het monster wat we gaan bestuderen. Vervolgens gaat het monster voor een nachtje op de droogstoof bij 60 graden. En wat er dan overblijft is droge residu. En dat is het materiaal wat we voor de analyse gaan gebruiken.
At first sight, it looks like just a bit of dry soil. But by magnifying it, a hidden world comes to life. Single-celled animals, skeletons of lobsters, needles of sea urchins, shells and grains of sand.
Kortom, van allerlei signalen die we kunnen gebruiken om dat oude milieu te kunnen interpreteren. Je moet denken aan een soort plas of een half afgesneden bocht van een kreek waar veel plantengroei omheen staat, riet staat. Als er riet staat, dan zal zoetwater ook niet zo ver weg zijn. Nou, dat zijn allemaal als eerste ideeën kun je dat opschrijven en dan kun je kijken of dat klopt met de bevindingen van andere disciplines.
Water and wind transport sand. The size of a grain of sand says something about how fast the water flows, as a faster flow is needed to move a heavier grain. Fine material suggests still water. But how do you measure the size of a grain of sand? Numerous chemical processes are used to extract 100% pure sand from the soil sample. All organic material must be removed from it. Only then can a laser beam measure the exact grain size. The composition of the soil determines how well archaeological remains are preserved. That is why we want to know how much lime and organic material sticks to the sand. We find out the exact composition by heating the material in steps up to 1000 degrees. And so, a small grain of sand gives us a large amount of information. This information is essential to find out about the landscape during that time. It's not only people that leave traces in nature, so do trees and plants. Everything that grows and blooms makes pollen. Every plant has its own distinctive pollen shape, which makes it easy to recognize. And pollen can be found in the soil. Using a microscope, we can discover which species of trees and plants used to grow in ancient landscapes. Some plants only grow in cold conditions. Others prefer a warmer climate. Here we see pollen from the birch tree. This is a tree that tolerates cold very well. And so, the type of pollen that we find reflects the climate. In addition to micro-remains of plants, there are also micro-remains of animals. In the subsoil, a hidden animal world of single-celled algae, foraminifera, and diatoms are present. Although they can't be seen with the naked eye, they give us a lot of information about the type of environment which existed. And the hard parts of these micro-animals are preserved in the soil. There are 2,000 types of diatoms. An expert can recognize the different species, which give detailed insights into their natural habitat.
Als we weten welke soort het is, weten we waar die voorkwam en weten we dus ook wat voor milieu het is geweest. Of het zeewater is geweest of dat het juist zoetwater is geweest.
Meanwhile, high up in the atmosphere, carbon molecules are formed, building blocks of everything that lives on Earth. Carbon is in every living thing, human, animal, or plant. The amount of carbon decreases after death, which allows scientists to date it. The less carbon, the older the material. This method is called C14 dating and is performed in a nuclear research lab, such as here in Uppsala.
We use this carbon dating because carbon can always be found together with human activity. Humans have always prepared food. They have made tools. And all these processes involve in some way carbon. And that's why carbon is so good for archaeological dating.
With this method, we can date seeds from trees and plants, and so we can find out the age of the landscape. If we date the archaeological finds, we know exactly when people lived. First, we have to isolate carbon molecules. This process involves a number of different physical and chemical steps. It is a very specialized technique, and there are only a few laboratories in Europe which can do these analyses.
And the basic for radiocarbon dating is that you measure the amount of radiocarbon. But the problem is that we have very, very few radiocarbon. So you need a very sensitive technique.
The University of Uppsala works with a new, faster and more precise technique. The different types of carbon molecules are sorted and counted with state-of-the-art equipment. The ratio of these molecules gives an exact date.
So we sort and count, and from that number we can deduce an age. That's the basic principle for this measurement.
Now that we have mapped the landscape with the core research, we can search specifically for the places where people used to live. These are mainly the high and dry parts of the landscape. With this drill, we collect larger quantities of soil samples, which may contain traces that people have left behind. All the sand is removed from the soil samples, and what remains is viewed under the microscope. An archaeologist immediately recognizes the finds.
Hier hebben we een groot stuk bewerkt vuursteen.
Specialists immediately identify an arrowhead that people used in hunting. They date this find on the basis of the shape and the type of flint.
Een ruwe schatting zou ik zeggen dat het ergens is tussen de 9000 en de 4000 jaar voor Christus. Kijk, in dit residu heb ik nu een verkoolde hazelnooddop gevonden.
This is a clear indication that people roasted hazelnuts in a campfire here. Thanks to carbon dating, we know exactly when this was, 9,350 years ago. Our past is hidden in the deep layers of the subsoil. Core drilling research makes it possible to reconstruct the ancient landscape of Almere-Oosterwolde.
En het is niet alleen een boorkern van de grond, maar het is een kern van de geschiedenis van de mens. En de geschiedenis van de mens in Almere.
Thanks to scientific research on the soil samples, we can also reconstruct this landscape. We know which plants grew here, what the climate was like, and where our distant ancestors lived in the landscape. Because we can also date the finds precisely, we also know when that was. At the bottom of the drill core, at a depth of 8.5 meters, lies sand. Seeds of dwarf birches have been found in this sand, so it must have been a cold climate. C14 dating shows that these trees grew 37,251 years ago on a kind of tundra. 25,263 years ago, it was extremely cold. The wind blew sand over the bare plain. It was too cold for trees, plants, and animals. Then, the climate became less cold, and the trees and plants returned. Mammoths and reindeer live on the tundra. At a depth of 6.5 meters, we find the seeds of conifers, birch, larch, and juniper from 11,420 years ago. In a relatively milder climate, a primeval forest can grow. Bears, red deer, moose, and aurochs live here. It's getting colder again. The primeval forest is dying. A thick layer of sand is deposited 10,266 years ago. The tundra is back. It is gradually getting warmer. The sea level is rising. The landscape is getting wetter, and the vegetation is increasing. Hazelnut shells and flint arrowheads, 9,350 years old, indicate the presence of humans. The sea level keeps rising. Marshes are created and peat forms. Seeds from the grass-like plant sedge are 6,981 years old. The landscape is getting wetter. Coastal marshes, freshwater marshes, and channels with natural levees begin to form. Deciduous forest grows on high ground. Man is hunting and fishing. Wild mustard seed, which prefers moist soil, is 5,839 years old. 4,000 years ago, large open water areas were created in the peat bogs. In the Lake Flevo core layer, a section of clay at a depth of 2 meters, we find seed from a swamp plant, 3,806 years old. Swamp areas are disappearing, and the sea level is rising. 2,000 years ago, a tidal marsh landscape with tidal creeks forms. In the late Middle Ages, from around 1250, the area changed into an inland sea and was given the name Zuiderzee. An enclosing dike is built in 1932, changing Zuiderzee into the inland bay IJsselmeer. Southern Flevoland is drained in 1967. The first houses in Almere are built in 1976. Drill core research not only brings back the history of the changing landscape, but also shows us how people reacted to the influences of climate and rising water. How, over time, they traveled through the landscape in search of the best place to live. The future residents of Almere-Oosterwolde are not the first residents in this area. And, just like their ancestors, they will add a new chapter to the history of Almere.